right, so second part of this lesson is solving logarithmic equations. They look messy. I've copied and pasted in my laws of logs from the previous video just to have them there in front of us so we can refer to them. So let's see. What ideally we want to move towards here when we've got lots of logs is to try and get log of something equals log of something. That's what we're going towards, okay? The example you're doing here on the right is going to be slightly different, but for our one, let's see what we can do. Now we've got an addition, so we're going to use law 1 on this, and we're going to turn this into x times 5, and the base is 3 and it's the same in both. So that is using law number 1, and that's equal to log of, do I have any laws for that? I don't think I do. It feels like it's in addition, but it's not, because look at your addition law. It's a log plus a log. This isn't a log plus a log. It's a log of a bracket. So I'm just going to leave it and do nothing and hope things will work out. All right, so I'll just tidy that up. 5x times 5 is 5x is equal to log base 3 of 2x plus 3. Remember in the indices questions, we said if the bases are the same, you can equate the powers. It's likewise here. You've got log base 3 of something is equal to log base 3 of something. So the somethings are going to be equal. And we take it from there. So we'll subtract 2x, 5x minus 2x is 3x is equal to 3. So x is equal to 1. So that actually wasn't too bad in the end. So let's have a look at your one. Your one again is an addition, but on the right-hand side, there's no log. So my hint for you here is to use the switcher law. And I'm going to go and copy the switcher law in here now to help you with that. Okay, if you resorted to your calculator at this point, perfectly acceptable. I use my laws of indices there to keep going with that. So if you're unclear about the laws of indices, look back on the previous lesson. All right, so what have we got here? What was the question again? It said to solve. So I need to find what x is. So, better get those laws of logs and bring them down again. All right, so what have we got? We have got a subtraction on the left. So let's turn that into a division. 5x divided by x plus 2. So that's the second law there. On the right, again, I've got a subtraction. So I'll turn that into a division over x. What have I got? Oh, actually, I'm back to the situation where I've got log of something is equal to log of something. And the bases are the same. So therefore, the somethings, the fractions, are the same. So I've actually now gone back into algebra 1 and algebraic fractions here. So what I'm going to do is I'm going to cross multiply because I have a situation where we've got one fraction equals one fraction. So go back to algebra 1 if you need a bit of help with this. X times by 5x is equal to x plus 2 times x plus 6. I'm trying to solve for x. So at this point, I'm just going to do stuff, do some, multiply up brackets and stuff like that. X times x is x squared, 2x and 6x, where's that? 2x and 6x is 8x, and 2 times 6 is 12. It's looking like a trinomial. Let's bring all the x, let's bring everything to one side and let it equal to 0. 5x squared minus x squared is 4x squared minus 8x minus 12 is equal to 0. You can go straight into factorizing at this point, but you might notice that you can divide across by 4. And if you notice that, it will make your working out a little bit easier. So x squared, divide by 4, and divide by 4 is equal to 0. I'm going to go for the double bracket. We learned how to factorize double brackets in algebra 1. There's a 3 and a 1 minus, I think, and plus. So x is equal to 3 and x is equal to minus 1. Okay, all going well so far. Let's look at this last one then. This one is for you. Oh, there's like logs on the left and a mixture of logs and numbers on the right. So I think the first step for the left-hand side should be okay. We've got a minus. What are we going to turn that into? On the right-hand side, it's not very clear. So it's not going to be very clear what to do with the half there. You might need to watch me doing it, but we're going to have to force a situation here where we're going to force this to be a log. Now, the hint I'm going to give you is that you notice all of your other logs are a base 4. If I wanted to turn this into a log base 4, what number would go here so that it would be equal to a half? So 4 to the power of a half is equal to what? Now we know a power of a half is the square root of 4. So what's going to go in that box? It must be 2. Where were we again? Oh, this is a bit confusing, isn't it? So log of 2 base 4 is equal to a half. Oh, I've sorted that out for you. I'll just move that out of the way. I've just turned the half into log of 2 base 4, so you can replace that and you should be able to take it away from there. So pause the video and have a go yourself. Right, x equals 6 over 5. A little bit challenging there. All right, there is one thing to notice here, and that's the fact that we've got an x is equal to -1. Now we're going to reject this -1. The reason is you can't take log of a negative number. The reasons for that are just more than I can go into here. We need to keep these videos a manageable length. So if x was -1, up here you'd have log of -1, and you can type it into your calculator if you want, and you'll see that it gives you back a math error, but it's just not going to work. So we're going to reject that, and the only answer there is x equals 3. So that's a sneaky little thing that's probably worth writing on a post-it and sticking it on your notes just so that it stands out, that if you've got log of a negative, you need to reject it. So that's the end of that section. In the next part of this video, we're going to look at another new concept, which is the natural logarithm. So it's all part of the same lesson, but this is the third part of it. Keep going now if you can. Maybe take a 5-minute break if you need to and come back to it.